The pie chart shows the distribution of the number of bronze, silver, and gold medals in a school's trophy case. What is the value of X? All right, so they're actually, you look carefully here, those are representing degrees, which some of you may not even see since it's so small. So that means that 2x degrees, 3x degrees is what they're really referring to. Now here, you see there's a right angle symbol, so that's 90 degrees. So just put that there at 90 degrees. So since you all know that the total number of degrees in a circle all the way around is 360, that basically means that 2x plus 3x plus 90 is 360. So that means that 5x is equal to 270, and therefore x is equal to 54. 54 degrees. Part B, write the ratio of the number of bronze to silver to gold medals in lowest terms. Okay. Let's see here. Well, the first thing I think we were going to need is what is gold in terms of an X. I think that will help us. So let's see here. We've got, let's just bring this down. I need some space here. So the bronze and silver make up 5x, right? And that's 75% of the total. And then the gold, which I'll just call y, I guess, that makes up 25%, right? Because it's 90 degrees, which is 25% of 360. So solving this, we get that y is equal to 5x over 3, I believe. Yeah. Okay, so then we know that the total, which is 2x plus 3x plus 5x over 3, that equals 100. Like 100%, if you're looking at trying to figure out percentages. And therefore, when we add all this up, we get 20x over 3 is 100, and therefore x will be 15. So that means that when you make this ratio of, what is it, gold to silver to bronze, gold is 5x over 3, silver is 3x, and bronze is 2x, right? So once x equals 15 is placed into that, this now becomes, oh boy, what does it become? 15 divided by 3 is 5, so it would become, well, we can just, I guess, substitute it in first, and then I'll do it. So this will be 30, this will be 45, and this will be 25, I believe, right? Okay, but we want to get it in lowest terms, so I think I can divide through by 5, and when I do, I get 5, 9, and 6. So that is the ratio of gold to silver to bronze. Okay, good. Part C, if there is a total of 80 medals in the trophy case, determine the number of bronze, silver, and gold. Okay, that shouldn't be too bad. So we figured out that gold to silver to bronze was 5 to 9 to 6, right? That's the ratio. So now they're saying the total is 80. Okay, so the total is 80, and we have to divide it equally in this ratio. So let's first add up these guys, 5 plus 9 plus 6 as the denominator, and that will give us sort of something to work with. So this is 80 over 20, so that's 4. So this basically has to be multiplied by 4. You have to multiply it by 4, and when you do, you get 20, 36, and 24, right? So there's 20 gold, 36 silver, and 24 bronze medals in this trophy case that started with 80 medals in total. All right. Part D. The trophy case begins with the same number of each type of medals as in Part C. A teacher then finds a box with medals and adds them to the trophy case. Then the ratio of the number of bronze medals to the number of silver medals to the number of gold medals is unchanged. What is the smallest number of medals that could be in the trophy case? All right, so we have, again, the ratio is the same, right? 6 to 9. Wait, hold on. No, I think it's right here, actually. I just have to copy it. I don't have to remember it. 5 to 9 to 6. Okay, so we want to maintain that ratio because it's saying it's unchanged. So I think that ratio is maintained as long as you just add this many. So we started with this. So we started with 20, 36, and 24. And if I just add 5 here and 9 here and 6 here, the ratio will be maintained. So this is like 25, and this is 45, and this is 30. Yeah. And then they're just asking what's the total. So 25 plus 45 plus 30. And I believe that's 100. So that's basically all this question is getting at. An airplane holds a maximum of 245 passengers. To accommodate the extra expense of transporting luggage, passengers are charged a baggage fee of $20 for the first bag checked, plus $7 for each additional bag checked. On one flight, 200 passengers checked exactly one bag, and the other 45 passengers checked exactly 2 bags. Determine the total baggage fees. All right. So 200 checked one bag. They're going to pay this $20. And then we add to that 45 people who pay $27, right? 20 plus 7 because they're checking in 2 bags. So 27. And then when you do this math, that's 5215. And I think that's it. Part B, on a second flight, the plane was completely full. Every passenger checked exactly 1 or 2 bags. If the total is 5173, how many passengers checked in 2 bags? All right. So same kind of story, just a little bit different. This time they give you the amount, and we have to sort of figure out how many are the 2 bag people. Okay. Well, the X I'll let be the 1 bag people, and therefore the 2 bag people is basically 245 minus X, right? Yeah. And I think that's it. That's pretty much the equation. I think wait, hold on. Well, this should be a 27. Sorry about that. It's a good thing I caught that. Yeah, so it's X times, jeez, X times 20. At least I'm catching my mistakes. So it's X times 20, which is $20 for the people who checked in 1 bag. And then it's 245 minus X times 27, which is the amount of money for checking in 2 bags. So then you just solve this equation. So it's 5173 is equal to 20x plus 6615 minus 27x. And therefore, this is going to be 1442 is 7x, and therefore x is 206. So 206 represents the people who checked in 1 bag. And, they want the number of people who checked in 2 bags. So that's going to be 245 minus x, which is 245 minus 206, which is 39. So 39 is the answer to that question. Part C. On the third flight, exactly $6825 was collected in baggage fees. Explain that there must be at least 1 passenger who checked in 3 bags. Okay. All right, so first, let's see, how do I approach this question? Let's say nobody checked in 3 bags, so everybody checked in 2. Okay. Yeah, so we had 245 people, right, on the plane, I believe. And let's say all 245 checked in 2 bags. So that means each of them is going to pay $27. That's the maximum before we start talking about 3 bags. If we're just talking about 1 bag and 2 bags, this is the maximum. All of them check in 2 bags. When you do that, you get 6615. Now, the total collected was 6825. So obviously, there had to be at least someone who checked in more than 2 bags in order for the amount to be 6825. So you can just sort of explain that in sentence format. I hope that makes sense. That you max out at 6615 if everyone checked in 2 bags. So obviously somebody had to check in more than 2 bags in order for you to get up to 6825. D. On the 4th flight, exactly $142 was collected in baggage fees. Explain why there must be at least one passenger who checked in at least 3 bags. All right. So the 1 bag people I will represent as A, and the 2 bag checkers I will represent as B. So therefore our equation, let's see if I can do it right this time, $20 times A plus $27 times B, and that is equal to this 142 that they are giving me. Okay, so now let's isolate this equation for one variable, or isolate it for A, and when you do, you get 142 minus 27B over 20. Now remember, the number of people who check in 1 bag and the number of people who check in 2 bags is an integer, correct? So we have to basically find integer solutions to this equation. So I have A and B, and let's see what happens. So first I'll start putting values for B, and I think the lowest value is 0, right? Because it can't be negative. So 0 people. And when you do that, you get 7.1. So that's no good because A should be an integer. We need to find integer solutions. When you put B equals 1, you get 5.75. When it's 2, it's 4.4. When it's 3, it's 3.05. When it's 4, it's 1.7. And when it's 5, it's 0.35. And then when it's 6, it starts turning into negative numbers for A, which obviously is not possible since A has to be a positive integer. So what we've shown is that there's no solutions here. No solutions. So that means this cannot be the case if we only have 1 and 2 bag people. We need to have at least a 3 bag person in order for this 442 to happen. So for example, if we had 4 people that checked in 2 bags, that would be 4 times 27, and 1 person who checked in 3 bags, it would be 1 times, what does it be? 27 plus 7 is 34, right? And this will give me the 142 that is desired in that question. Cards in a deck are numbered consecutively with positive integers. The cards are selected in pairs AB with A less than B to create a given sum A plus B. For example, Anna has a set of cards numbered from 1 to 50, and she is required to create a sum of 60. 2 of the pairs that she could select are 10, 50, and 25, 35. Emily has a set of 10 cards numbered exactly from 1 to 10. There are exactly 3 pairs that she can select, each having a sum of 8. List those pairs. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the numbers, and then we want to create 3 pairs that have a sum of 8. Okay, so let's see. We can have a 1, 7, a 2, 6, a 3, 5, and I think that's it. Because you have to keep in mind that A has to be less than B. So that's sort of the one of the important things to remember. And that's it. So there's basically 3 pairs, and those are the 3 pairs. Silas has a set of 10 cards numbered from 1 to 10. He can pick pairs that have a sum of 13. Okay, so determine those guys. Okay, so the same list here that we have up here, but now we got to add up to 13. So 1 and 10, that doesn't work. So I guess we have to start with 3 this time. 3 and 10 is the one that will work, and then 4 and 9, that will work. 5 and 8, 6 and 7, and is that it? I think so. So there's 4 pairs this time. All right, moving right along. Daniel has a set of K cards numbered consecutively from 1 to K. He can select exactly 10 pairs that have a sum of 100. What is the value of K? All right, so this time we have 1, 2, 3, dot, 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 all the way to k. So k minus 1, and then k. And we are now going to select 10 pairs that have a sum of 100. Okay, sum of 100. Okay, so how do we do this? Well, we have to start actually giving values for k to see what actually would happen. So for example, if k is, say, I don't know, whatever, 10, like in the previous question, there's no way to get a sum of 100, right? Because even if you added 9 and 10, it would be 19. So we have to get at least a 50. So if k was 50, then it would be basically the numbers 1, 2, 3, dot, 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 all the way till 49, 50. And then if we took the two largest numbers and added them, you'd still only get 99. So I believe that k has to be at least 51. Yeah, in order for at least to get something. So that would be 1, 2, 3, all the way up to 50, well, 49, 50, and then 51. In order to get a sum of 100, we could, I'll just list the pairs over here, 49, 51, that'd be one pair. That would be a sum of 100. So, but we want 10 pairs. Okay. So this, although works, it doesn't qualify for our condition, which is 10 pairs. Okay, so at least I'm on the right track here, that I'm showing that it could work for, you can produce at least one pair when k equals 51. But for k equals 50 and less, you won't even be able to produce one pair. Okay, so let's keep going. K equals 52, what happens there? 1, 2, 3, dot, 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 49, 50, 51, 52, right? So let's see if we can get any pairs. 49 and 51, that's there again. And 48 and 52, that's another pair. So we got 2 this time. And my instinct is that as you keep going up by 1, you're going to get an additional pair. So for 51, you got 1 pair. For 52, you got 2 pairs. For 53, you'll get 3 pairs. And I'll let you list them. And it's pretty straightforward. So to get 10 pairs, which is what we want, you would have to go up to, I believe, 60. Yeah. So when k equals 60, then you'll be able to get the 10 pairs, and then you can list them. I'll let you do that. Okay, now we are 3D. Derek has a set of 75 cards that are consecutively labeled 1 through 75. Exactly 33 pairs that have a sum of S. Determine all possible values of S. So we have 1, 2, 3, 4, all the way till 73, 74, and 75. And very similar to the last question, we have to create pairs, and we have to create, in particular, 33 pairs. So they're basically saying, what is the value of S, where S represents not the number of cards, because that we already know is 75. S represents that sum. So if you took a pair and added the A and the B, right? Our pairs are of the form AB. That S represents A plus B. Got it? Okay, so how do we approach this? So what we have to do is we have to break it up into odd and even. First we look at when S is odd, and then later we'll look at when S is even. If S is odd, that means S is of the form 2k plus 1, because all odd numbers are of the form 2k plus 1 or 2n plus 1, whatever. So our pairs, if we, let's see here, if I start on this side, could be 1 and 2k, right? Because the sum is basically right here, a plus b. So that's how I get 2k plus 1. And then the next one would be 2k minus 1, right? Just moving right along. And then just kind of keep going like that all the way to the very end. It'd be k minus 1, k plus 2. And then the very last one would be k and k plus 1. Because then the sum would be 2k plus 1. Okay, well, the very last one, let me think about this for a second. we have only 75 cards, so that means that we're kind of limited as to how far we can go here. Like, for example, this 2K, for example, even if we had the very largest number, 2K has to be 75 or less. So that kind of gives us a little bit of a parameter there. So that means K is less than or equal to, what is that, 37.5, I think? Okay. All right. And then the most important thing in this question, of course, is that we have to have 33 pairs. 33 pairs. So since this is in consecutive order, we got 1, 2, 3, 4, all the way. This has to be 33. So that means K in this case has to be 33. Yeah. So that means that these guys are basically 166, substituting K equals 33, 2, whatever that is, 65, I believe. Yeah. And then dot, 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 all the way till 32 and 35. And then the last one would be 33 and 34. And therefore the sum S is 67. Yeah. Okay. So that's good. We got 1. And keeping in mind, this is for S is equal to, S is odd. Now we're going to stay with S is odd, but this time, let's see if I can fit it into one screen. I'd like to have it there, kind of show you. The other way is, you see here we started with 1, right? We sort of started at the left side of that whole numbered cards. But this time I'm going to start on the other side. I'm going to start over here. So at the very beginning, I'm going to pair up 75 with something. Now keeping in mind that the sum still has to be 2K plus 1, so this guy's got to be 2K minus 74. And that way when you add this and this, you get 2K plus 1. So I'm doing the same thing, but the only difference is I'm starting on this side instead of starting on that side, which is what I did over here. Okay, keep going, and this will be 2K minus 73 and 74. And then just kind of dot, 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 keeps on going. And then to the very end, you get K minus 1 and K plus 2. And K and K plus 1. I believe that is correct. Yeah. Okay, and then the same kind of story that we need 33 pairs. So that means that if you're counting down from 75 to 74 down the way, all the way to K plus 1, that means that K plus 1 has got to be 75 minus 32, right? So that means 43. So that means K has to be 42. Because there's got to be 33 of these guys. 1, 2, all the way down to the 33rd. And then therefore, once I have the K value, I can just substitute it back into these guys. And when I do, I get 10 and 75, 11 and 74, and so on, all the way to 41 and 44. And the last one, I believe, is 42 and 43. And then therefore, the S in this case is 85. All right, great. Okay, so we done the S is odd. Now we proceed to when S is even. That means S would be of the form 2K, since all even numbers are of that form, 2K, 2N, whatever variable you want to use. And the same kind of story. You're going to look at your cards and sort of just see what kind of pairs you can get. Let's start on this side this time. So 1, and then I'd have to add 2K minus 1, because remember the sum this time is 2K. And then it'd be 2K minus 2. And then you kind of keep going. K minus 2, K plus 2, and then K minus 1, and then K plus 1, like that. Got it? So we have 33 pairs like that, as always. And then we're going from 1 to 2 all the way to 33. So that means that K minus 1 is 33. And if that's the case, then K is 34. Substitute K equals 34 back into that guy, And we get 1 and 67, 30, all the way to 33 and 35. I'll let you list them all. You don't need to list them all. I mean, I don't think that is even required because you'd have to list 33 pairs, and that's just, you can list, I think, the first two and the last two, and that should be sufficient. So this time S is what? 68. And then we have one final one where S is even. And that one would be starting on this end. So I think I had done that for the previous one. So this time we're starting with 75, and then this is going to be 2k minus 75 because we want the sum to be 2k. And then this is going to be 2k minus 74, 74, dot, 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 all the way down to k minus 2, k plus 2, and then the very last one would be k minus 1 and k plus 1. Yeah. And then as always, we have 33 pairs, so that means that when you're going 75, 74 on the way down, this guy, this k plus 1, is going to be 75 minus 32, which I believe is 43, so therefore k is equal to 42. Sub k equals 42 into that guy, and you'll get 975 all the way down to 41 and 43, and therefore S here is 84. So those are my values of S. I got 84, 68 for when S is even, and 85 and 67 for when S is odd. A circle of radius 2 and a circle of radius 5 are externally tangent to each other at T and tangent to the horizontal line at points P and Q. If points O and C are the centers of the circles, then OTC are collinear, and both OP and CQ are perpendicular to PQ. By constructing a line segment passing through O and parallel to PQ, determine the distance from between P and Q. All right. So they're giving you a little bit of a hint there. That's nice of them. So they're basically saying, draw a line between from O, that's, parallel to PQ. Okay, so then when you do that, I'll just draw it up here, make it a little bit bigger. We have this OC and whatever you want to call this guy, M, let's say, that point right there. And that's, of course, going to be a right angle, since this is a right angle. And then we just use Pythagoras, I think. That's pretty much it. So PQ is the same as OM. So this OM squared plus CM squared will be OC squared. I think that's pretty much it. Okay, so CM, that is, what do we have? 2 and 5, right? So if this is 2, then the C to Q is 5, so CM would be 5 minus 2, which is 3. And then OT is 2, CT is 3, so OC is 5. So this is 5. Oh, sorry. Hold on. CT is 5. Sorry about that. So that means OC is 7. 7 squared. CM is 3 squared. Well, CM squared is what I mean. And then OM squared. So then when you solve this, you get OM squared is what? 49 minus 9, which is 40. So that means OM is root 40, which would be 2 root 10. And that's pretty much what represents PQ. Since PQ is equal to OM, PQ is also 2 root 10. And that's it. A circle of radius 4 has a circle of radius 9 tangent to the horizontal line at points D and E. A third circle can be placed between these two circles so that it's externally tangent to each of the circle and tangent to the horizontal line. DE is 24. Determine the radius of this third circle. All right. So I have to attempt to draw this diagram. But I won't. I'll just draw the circle sort of there, and that should be sufficient. Okay, so now I've got to explain this question. Now, in my opinion, the hardest part about this question is trying to figure out whether when you go from the center here to the center here, through the center here, is it going to be a straight line? And the answer to that question is no. And I think that is in my opinion, that's the key to kind of not going down the wrong path. Because when I draw it, it's going to look like it's a straight line, but it actually isn't. So let me see what I can do. So as you can see, it's from the diagram, it just still looks like it's a straight line, but it's not. And I think that's what kind of trips people up. Because if you go in the straight line direction or in that path, you will get the wrong answer. So let's just label this. So this is 4 according to the question. And then the bigger guy is 9, I believe. So this is 4, that's 9, and that's 9. And then this, in the middle, we don't know, right? So I'm just going to call it R and that kind of thing. So then what I'm interested in first is this guy, that segment, that's going to be 9 minus R. And then I'm interested in this segment here, which is going to be, I believe, R minus 4. Yeah, R minus 4. And then D to E, that segment, they told me is 24. So from D to here, I'm going to just call that Y for now. And then from here to here, that's going to be 24 minus Y. Yeah. And I think that should be it to figure out this question, those measurements. So let's see. The first triangle, this guy right here, this triangle right here, using Pythagoras on that guy, we're going to get y squared plus r minus 4 squared is equal to 4 plus r squared. Correct? And then we're going to have one more triangle, this guy, this triangle. That one will give me 24 minus y squared plus 9 minus r squared is equal to 9 plus r all squared. Okay, so we got two equations, two variables. We should be able to solve this for both y and then for r. R is really what we want. They want the radius of that third circle, which I have called r. All right, so here we go. So this guy is going to give me y squared plus r squared minus 8r plus 16 is equal to 16 plus 8r plus r squared. When I simplify this, I just get y squared is equal to 16r. And therefore, I guess r would be y over 4. Yeah, when you bring it to the other side and take the square root. Wait. Root r. Sorry, root r. Because I had to take the square root of both sides. Okay, now over here, let's see here. Let me just keep this 24 minus y squared. I think I'll be able to simplify this guy a little bit quicker. This is, let's see here, 81 plus minus 18r plus r squared. And this is 81 plus 18r plus r squared. So that means this 24 minus y squared, 24 minus y all squared is, the 81's canceled, r squared's canceled, so I just have 36r, I believe. Okay. So now what I'll do is I will substitute this guy here, this finding. So let's take the square root of both sides first. And when I do, I get 24 minus y here. And here I get 6 root r. And then since root r is y over 4, I can substitute that in. So 24 minus y is 6 times y over 4. And then I have 24 is equal to 10y over 4. And therefore, solving this, it would give me, I believe, 96 over 10. So y is 96 over 10, which is 48 over 5 in lowest terms. And then now I can easily just substitute it back into there to get r. So that means that, or substitute back into here. So that means 48 squared over 5 squared is equal to 16r. And when you solve that and reduce it to lowest terms, you get r is equal to 144 over 25. So that is the radius of that middle circle. Part C. 3 circles with radii r1 less than r2 less than r3 are placed so that they have this horizontal line and they're adjacent and externally tangent. F, G, H, I, J, K are points of tangency to the horizontal line. The lines F, G, H, I, J, K are 18, 20, and 22. Determine with justification the values for R1, R2, and R3. So it's the same story as before. The only difference is now we're going to have a lot more variables. I believe we're probably going to have 6 variables and therefore 6 equations, right? Two from, well, let's just see how this goes here. So the way you draw these triangles are pretty much the exact same way. So I'm just going to, draw them in. The way I did before, where we're hitting the center like that, and in a very similar way over here, like that, and then like this, and then in a very similar way, let's see here, I believe like that, and then going to be something like this, I think. So, I mean, it's not a work of art, but you guys get the idea. And then you can label them. I'm actually going to draw them here and label them because it's a little bit less messy to do that. When you label them on this guy, it's R1 plus R2. And then this, I don't know, so I'm just going to call it Y. And this is R2 minus R1, I believe. Yeah, this side right here. And then this triangle, it's 18 minus Y, right? Because I'm from F to G is 18. Yeah. And then this side here is going to be R2 plus R3. This side here, R2 plus R3, and then this side on the side is R3 minus R2, I believe. Yeah, R3 minus R2. Okay, in a very similar way, I'll just do it really quickly this time instead of talking you through it. So again, I've got to label these guys. So let's label them. Again, this is going to be X. 20 minus X, because I'm using 20 this time. And then this is R2 minus R1. R2 minus R1. This is R2 plus R1. And this is R3 minus R1, I believe. And then this is R3 plus R1. And then finally this guy over here, we got this triangle. And then we got that triangle. So this time we're using 22, and then we use whatever variable you want to use. You can use Z. Say Z 22 minus Z, and then this side is R3 minus R2. So R3 minus R2. This is R3 plus R2, and then this is R3 plus R1, and then finally this is R3 minus R1. Right? Okay, good. We got the triangles. Okay, so now that we have the triangles, we need the equations. So the equations are very similar. It's just Pythagoras. So it's y squared plus R2 minus R1 squared is equal to R1 plus R2 squared from this triangle right here. And then the next one would be 18 minus y squared plus R3 minus R2 squared is equal to R2 plus R3 squared. So that takes care of these two guys. Then these two guys will give the following equations. X squared plus R2 minus R1 squared is equal to R2 plus R1 all squared. And then 20 minus X squared plus R3 minus R1 squared is equal to R3 plus R1 squared. And then finally these guys, that's going to be Z squared plus R3 minus R2 squared is equal to R2 plus R3 squared. And then finally, 22 minus Z all squared plus R3 minus R1 squared is equal to R3 plus R1 all squared. Okay, so that's basically the equation. So we have 1, 2, 3, 4, 5, 6 equations. And my variables, I think I have 6 variables, right? R1, R2, R3. And then I introduce the next Y and a Z. So I got 6 equations, 6 variables. So that means that this can be solved because the number of equations should equal the number of variables. All right, so then how do we solve this? Okay, so what I will do is I will just do, it's very long, but the good news is that once you do it once, it's the same thing over and over. So I'll just do the first one, which is I'll look at equation 1, which is this guy here. And I'll just do that one. So it's y squared plus r1 squared. Well, I'm putting it actually, yeah, hold on. R2 squared minus 2r1 r2 plus r1 squared. And that equals r1 squared plus 2r1 r2 plus r2 squared. Right? Okay. So that means y squared is equal to, let's see what cancels here. This cancels, and then therefore we just have 4r1 r2. So therefore y is equal to 2, the square root of r1 r2. Okay? All right, so that is the only one I'm going to do. The other ones I'll let you do, meaning expanding them and collecting like terms. And when you do, you get the following. You get 18 minus y is equal to 2r2 r3 square root. You get, that's actually what you're getting here. And then I'll keep going here. I'll just write them out. The next one, you're going to get something similar. So first, before I continue, let me just talk about this. Y and 18 minus y. Y was representing from here to here, and 18 minus y was representing from there to there. And the whole thing, FG, is 18. So that means that FG, which is 18, is y plus 18 minus y, obviously. So that means 18, if this is y, is 2 root r1 r2 plus 18 minus y, which is this guy. So 2 root r2 r3. That's what I wanted to show you. So that is basically how we're going to approach this. And very similarly, you can show, this was FG, that HI is, which is x plus 20 minus x, is equal to 2 root r1 r2 plus 2 r1 r3 root. And of course you're going to get this from the other two equations. So those other two equations, I believe, are this guy and this guy up there. And therefore, HI was what? Equal to, what was HI? HI was 20. Okay, so HI is 20. So that means that 20 is equal to this 2 r1 r2 root plus 2 r1 r3 root. And then similarly, we have the last one, which would involve this guy, and that's j to k, and that was 22. That is going to be j to k, which is 22, was z plus 22 minus z, and therefore 22 is going to be, when you expand and collect like terms, 2r1r3 plus 2r1r3 r2r3 like that. Yeah. So let's see if I got this. I think so. I think this should be okay. So basically, you guys understand this one. I just didn't do all the algebra there. I'll let you guys do that. Okay, so now that we got these results, let me just circle them. We got this result, we got this result, and we got this result. Now we can proceed. Probably going to want to simplify it a little bit. So what I'm going to do is I'm going to let this R1, R2 guy equal A. And then I'm going to let this R1, R3 guy equal B. And then this R2, R3 equals C. Like that. Got it? Okay. So then, when we substitute that in, you get 18 is equal to 2a plus 2b. And then 20 is equal to 2a plus 2c. And 22 is equal to 2b plus 2c. And these are very nice, equations. And then when you solve them, I'll let you solve it. You'll get a equal to 4, b equal to 5, and c equal to 6. So therefore, that means that when you substitute these values back into these guys, you'll get the following. That this r1, r2 square root is 4. So that means r1 times r2 is equal to 16. And then similarly, r1 times r3 is equal to 25. And r2 times r3 is equal to 36. Okay, so we're getting somewhere. And then to solve, we will take those three guys and multiply them together. And when you do, you get r1 times r2 times r1 times r3 times r2 times r3 is equal to 16 times 25 times 36. All right, so what happens now? We'll take the square root of both sides, because this becomes r1 squared times r2 squared times r3 squared, right? Is equal to 16 times 25 times 36. Just take the square root of both sides, and you get r1 times r2 times r3. And that would be 4 times 5 times 6, which is 120. Okay, we are almost done. Now to get the individual values of r1, r2, r3, you just have to divide. So you have to take this guy, r1, r2, r3, and divide by, say, r1, r2. So this top number we know is 120. r1, r2 is 16 from over here. So this would give me r1 divided by r2. Well, what happens here is this cancels with this, so then you just get r3. So you end up with r3 is equal to 120 over 16. And whatever that is, I think it's 15 over 2. I think so. Divide 120 by 8, right? So 60 by 4. Yeah, it's 120. It's 15 over 2. And in a very similar way, you can get the values for r2 and r1. I'll let you do that. So r2, I believe, ends up being 24 over 5. And r1 ends up being 10 over 3. And there you go. Those are the radii of those circles.